Hey everyone, welcome back to my YouTube channel Geeky Codes. Today we are solving a really interesting problem, binary tree from LeetCode called leaf similar trees. But before we start, if you are new here, do not forget to like this video and subscribe to my YouTube channel and hit the bell icon so you never miss out on any of my coding tutorials. So let's read this problem. We are given two binary trees. We need to check if their leaf value sequences are same. And here what is leaf sequence? It's just the sequence of values from all leaf nodes read from left to right. For example, we have this tree and the leaf nodes are 6, 7, 4, 9, 8. And since we are reading from left to right, it is 6, 7, 4, 9, 8, and this is the leaf value sequence of this tree. And now if both trees have the same leaf sequence, we say they are leaf similar, otherwise they are not. So in this example, we can see that first tree has 6, 7, 4, 9, 8. That is its leaf sequence value. And for the second tree, we can see that it is also 6, 7, 4, 9, 8. Since we can see that both trees are different, but their leaf sequence values are same. So we can see they are leaf similar trees. And in this example, we can see that first tree has leaf sequence 2, 3, but second tree has leaf sequence of 3, 2. And they are not same. So output should be false. How do we solve this? Step 1 should be traverse the first tree and collect all leaf values in a list. And step 2 should be traverse the second tree and collect all its leaf values. And the third step should be comparing these two lists. If they are equal, return true, otherwise return false. And we can do this easily using depth first search or recursion. So let's write solution for this one. Inside this leaf similar function, we will define a helper function to get leaves, and that should be get leaves, and it will pass a variable called root, and we will create a list equal to list of leaves, and that should be leaves is equal to empty list. And then def, we are again defining a function called dfs, and it will be passed a node inside this function, and if not node, then return, and if not node dot left and not node dot right. That means if some node does not have any left or right, then it means it is the leaf node, and it should be leaves dot append node dot value. This means that in the leaves list we will append this node value, and then again we will do same for dfs of node dot left, and similarly for node dot right, and at the end we will return dfs of root and return the leaves list, and in the end we will return get leaves of root 1 equal to root 2. Here we have defined a helper function to get leaves, which runs a dfs on the tree, and whenever it finds a leaf node, that means node with no children, it stores the value in the leaves list, and finally it returns the list of like leaf values. And then we call this function for both trees, that means root 1 and root 2, and we compare them. If it is both values are same, then it returns true, otherwise it returns false. So let me try to run it and check if it works for our test cases or not. As we can see that our solution passes these two test cases, and time complexity of this solution is big O of n plus m. Here n and m are the number of nodes in both trees, and we are visiting each node once, that's why it is only big O of n plus m. and space complexity of this solution is big O of n plus m, that is for storing the leaf sequences. So now let me try to submit it and check how does it perform compared to other users in terms of space complexity and time complexity. As you can see here that our code passes almost 73.59% of users in terms of memory and 100% of users in terms of runtime. So that's it for today's video, and if you found this explanation helpful, do not forget to hit the like button and subscribe to my YouTube channel Geeky. Share it with your coding friends and comment below which lead code problem you would like me to cover next. Thank you for watching and see you in next video.